Welcome everyone to another little video on the rocks looking at some deepwater outcrops. We are in the Carboniferous on the west coast of Ireland. The Ross Formation, which is quite a well-known and well-studied deepwater formation. We're actually standing right here on top of what is called the Ross Slide. And as you can see over in the distance here, that's a package that is mud dominated, although it has a lot of sandy units inside of it and it's very heavily deformed. So I would probably call it a slump as a unit, but it's a small mass transport complex. But what we're really interested in here is the units that sit on top of that slump, which is a deepwater turbiditic complex that we'll go and walk through, talk through some of the observations that we can make on the outcrop and how we interpret it. This time I'm joined again by Chris of Geology Field School and with Brandon, one of my co-workers here. So Brandon will assist in kind of pointing a few features out. So let's look at the first unit that we see on top of here. So where Brandon is standing, it's about a 2 meter thick interval, and the first thing you can observe is more recessive units that are grey colored, that look more muddy, and things that are a bit more resistant to weathering, that have this brownish color, that end up being the sandstones. So when you look at that unit and you try to sort of figure out what's going on in there and describe it, one of the things that's interesting in here, the very basal part, if Brandon kind of pointed at, is mud dominated, but there's a lot of little lighter colored beds in there that are little isolated ripples. So they're interbedded thin sands and muds in there. Now you have to kind of look carefully. You can't quite see it here, but if you chop off some pieces, you'll actually see that the muds are fairly poorly sorted and the sands are fairly poorly sorted as well. So these are not fully turbulent flows. They're starting to become more laminar. They're not quite debris flow yet, but they're what we call either transitional or hybrid flows. Or slurries is another term you'll hear people use. So those kind of thin-bedded intervals are fairly poorly sorted sands and muds, so they're dominated by these slurry beds. One of the nice things when you look at the sands, all the sands here are really very fine-grained to maybe fine-grained, so you don't get anything coarser in the sands here. But you see some really nice bed forms in the sands where Brandon is. If you can point to those, you can kind of see that undulation on there. Those are ripples, current form, but I used to call these chunky ripples because they're a little bit bigger than a typical current ripple. And these are probably actually small antidunes, if we look at some of the lab experiments on making these bed forms. So we're starting to see some bed forms that are being formed by traction. They're very well sorted sands, so the flows are turbulent, so the mud is being kept in suspension. So they're forming these ripples and then these short antidunes in here, which increase slightly accelerating flow velocities. As you get to the thicker sands in here, and again Brandon can point to it, you'll actually see some really nice scour surfaces on the sands. So again, they're turbulent flows and these eddies are scouring, and it's hard to see on these rocks because they're so homogeneously fine-grained. And we'll kind of point out to that as we see them, but there's some larger scale bed forms in there, mostly dunes, so you see some cross stratification in there. So, and then you can see that motif repeated again in this next little unit in here. So the description here would be about 2 meters of interbedded slurry beds and very fine sands with ripple and dune cross stratification. So 2 faces in here, and there is a little bit of a stacking motif in here, so you generally see that the sands get more common and thicker as you go up in this unit. So you can call this unit a thickening upward unit. I wouldn't necessarily use coarsening up because the grain size in the sands is pretty much fine to very fine. So that's that first bench of 2 meters, what we can see in there. So let's walk to the next bench and see how this changes. So right here we're standing on the top of the sand of the lower bench. There's a few more sands above that before you again get into that motif of this recessive unit, which again has little isolated ripples in there of sand. You can actually see quite nice in here if you zoom in here, Chris. You know, this kind of muddy unit is actually really poorly sorted sand and mud. It's really not a clean sand or a clean mud at all. So again, these are being deposited by flows that are starting to lose their turbulence. Okay? So these are hybrid flow beds. Again, the sands scoured bases, and actually the surface that we're standing on is kind of hard to see, but you see that sort of slight undulation. So these are cross stratified sands that are mostly, as we look at current directions, are migrating out that way towards the east northeast. So we're starting to get a sense of the current direction, where down dip is that way and up dip is in that direction here. Now, so the second bench, it's a little thicker. The total thickness, as you measure the whole thing, we got to about 4 meters. It's got the same two facies, essentially slurry beds and fine sands with cross stratification in them. So again, the same two facies that we've seen before, but now the whole unit is a little thicker, and it also has a little bit higher net to gross. So we see more sand, and the sand beds are thicker as well. So we see an increase in net to gross and a thickening up compared to the previous unit. And again, internally you can convince yourself that generally as you go up for the unit, you see the individual sand beds get thicker and thicker and thicker as you go up. So it's another thickening up unit, but the same two facies as the last bench, a little thicker, a little higher net to gross. Okay, let's kind of go up to the last bench and then we'll kind of talk about what it all means. So now we're standing on the top of the sand, which is the top of our second bench, and we're looking out over kind of the next unit, and there's some more stratigraphy behind there that we'll kind of leave for now, but we'll get the motif with this next bench in here. And what's kind of interesting in here is that we still see a few sands. You know, Brennan, if you walk over that way, we'll kind of hang back a little bit here, Chris. So up to sort of Brandon's hip, there are a few more sands that are fairly tabular, and then on top of that you see a fairly recessive unit. So instinctively you go like, okay, I understand these are these sort of interbedded muddy and sandy things that are not quite turbulent, not quite laminar flows, these transitional flows. But as you can see, it looks a lot more chaotic. So you can see a lot of surfaces in the sand come down, and you can also see a lot of isolated bodies where Brandon is sitting of sand that seem to be going nowhere. So let's go and have a close-up look at that and see what that really looks like. So one of the things that you'll see here is that rather than depositional beds of poorly sorted sand and mud, or slurry beds if you want to use that term, you can see where Brandon is. You can see that this is actually all composed of clasts of that material with sand in between. So this is really what we call a shale clast rip-up brachia. So you'll see this, and if you see this in core, you'll see these angular shale clasts with sand, and you can see that in places that continues into more bedded materials in here, and then it gets ripped up, and it gets ripped up right on the top of this scour surface on the sand. So these scour surfaces are really formed by very significant eddies that make very big scours in here, and they rip up a lot of the underlying slurry beds into this shale clast rip up with the sand. In this case, on this surface is not much sand preserved, and that sand is probably bypassing into the basin off towards the east here. So those kind of scour surfaces for shale rip-ups are quite common at this point. And then, you know, as you trace this outcrop around, you'll start picking up a lot of those surfaces. It's really interesting, especially as you kind of come up a little bit here. You'll start seeing these surfaces actually, whereas before most kind of bed form surfaces are dipping downflow into the direction of the transport, we're starting to see some inclined surfaces now that are actually dipping back into the direction of flow. So those could be actually large-scale backsets associated with cyclic steps in this system. Now, very often you'll hear, typically when people see scour surfaces in deepwater systems in outcrop, they'll very often use the C word, being channel. So they'll say, oh, there's a channel, and you just have to be careful in that, you know, for something to be a channel, it has to have that channel morphology, and be aware, in a lot of places in the deepwater system, you get a lot of scouring of these turbulent flows that can create very, very large scale scour surfaces that in a 2D cut could look kind of smiley shaped. But if you look at them in 3 dimensions, they're not actually a straight channel, but a part of a large scoop surface. So that's kind of the observations here. Still, the coarsest grain stuff we get here is no better than about fine grain sand. So low facies diversity, not a lot of very coarse material. But you know, what does this mean? Okay, so now Brandon and I measured the section here, and I just try to sketch what we measured. And this is kind of what you would interpret here in terms of this in the stratigraphy. So you've got this lower bench we walked on first, a couple of meters of interbedded slurries and sands with some ripples, maybe some chunky ripples, some trough crossbeds, and then the muddy intervals are really quite poorly sorted, and these slurry flows, and it internally thickens up, not so much coarsens up, but really thickens up in the sand. And the second bench a little thicker, and then the third bench thicker, and now we're starting to see the muds here are actually composed of shale rip-up breccias. So if we interpret this, we could say, you know, if you were on a well log, you typically say, well, this is my A sand, it's a couple of meters thick, sort of moderate net to gross, my B sand and my C sand. And from the outcrop I can see that I'm in a fairly distributive system. There's not a lot of confinement here, so I can put myself into that facies diagram that we'll show you in a little bit again. And that, say, at the base I'm in a medial lobe, so we'd probably call the whole unit, the 2 meters, a single fill, in this case a lobe composed of a number of elements. And then I'm in the proximal part of a lobe, and then ultimately where I get all these scour surfaces, I'm in the channel lobe transition, where I get very rapid deposition, all the shale class breccias. So again, that motif that we've seen in our last video as well kind of puts you into that motif. So basically where we're standing here, we're looking at a kind of going back to this diagram. This was from a previous video we did, but initially we're standing probably more in a medial position of the lobe in the first bench, getting to a more proximal position on the second bench, and ultimately in the channel lobe transition in the third bench. Now obviously we're not moving, so we're standing at a stationary spot, so that means that we're looking at a system that is advancing towards the east, or prograding if you prefer that term, but we're looking at an advancing lobe complex where the basal part is in a more medial position, the second bench the more proximal, and ultimately we get into a channel lobe transition. So far so good. At this outcrop we're happy that we're going through an advancing lobe complex, and we're more medial, more proximal, and more channel lobe transition position, and we can put in some genetic surfaces, and often you'll see people say, oh, that's my A sand, my B sand, my C sand. So far so good, everybody happy. Now let's go to the next outcrop and make sure that we correlate this properly. Alright, so we've come a couple of kilometers down depositional dip from where we were last time, towards the east. We're at a point called Fisherman's Point here, and we're standing on the same surface as where we were at the Bridges of Ross, on the top of this slumped unit in here, with some nice sand volcanoes in this case. But again, we're standing on the same chronostratigraphic surface as where we measured our sections last time. So we're looking at roughly age equivalent age stratigraphy. So we've kind of talked through the lithofacies in more detail in the last stop, so we'll go a little bit faster, but just as the last time, you can see that the more muddy intervals tend to be more recessive, and the sandstones tend to weather out and be sometimes a little bit buff colored. So again, you can see mudstones with still some very thin little ripple laminated isolated ripple sands in there, and then you get these thicker sands, very fine grained, with just subtle hints in this case of bed forms again. So you can see slight undulations on there forming these current ripples, and what we call these chunky ripples, short waveform antidunes in there. So you can kind of see similar stacking patterns as we saw in the last outcrop, where you get more sand as you go up through a package. So you see a thickening of sand, increase in net to gross, not really a coarsening up. It's not really a term you'd use because you're still dealing with very fine sand. Okay, and then there's a little bit of a bench as we kind of got used to, so a step back of the next unit, and the next genetic unit again starts with some mud in there. But now again, just as we saw in the last outcrop, we start seeing some more significant surfaces in here, In this case, again, you can see that cutting surface that comes down here, comes around here, and then it kind of steps up onto a sand there. And while from a distance it looks like mud, and it is predominantly mud, this again is one of these areas where if you look in great detail in here, you can see just lots of clasts of mud ripped up and displaced with sand in between. So this is again one of these what we call shale rip-up clasts breccias. So they form by turbulent eddies, quite significant eddies that are eroding into the muddy substrate and creating these kind of breccias. So they're quite a high energy facies in here. And then, you know, above that we can see these stacks of sand bodies. Again, you know, the tops are fairly undulating, so there's lots of bed forms in here. So most of the sand here is being transported and deposited by traction, with some very thin intermediate caps that are dominated by these little thin slurry deposits in here. So you get this motif again of thickening up compared to the last package, and on the top here we won't walk that out this time, but at the top there is another ledge, and then you get another unit that becomes even thicker. So pretty similar to the last outcrop. So if we kind of look at that in the sketchbook, we can see I'll come around this side and just to stare in the sun for you guys. So again, we can measure a section through here, and we can see a basal package that is mostly fairly recessive with some thin sands. Again, a little bit of thickening upwards in there, so it's a couple of meters thick. You can call that the A sand, just like we did last time. There's a second unit that's about 5 meters thick, the base of which has these shale rip-ups that we just looked at, and a stack of some amalgamated sands with trough crossbeds inside of them. And then a unit above that we're not really looking at here, but very similar to what we saw in the last outcrop. We see some fairly significant scour surfaces. We've got some pretty cool drone footage of that actually, and some long waveform bed forms, and again getting very sandy. So overall, you might say I got an A, B, and C sand, and each unit internally thickens up in the sand, and each unit becomes progressively higher net to gross and thicker bedded. Okay, so then you go, okay, we got these two measured sections in here. Okay, so now we're looking at the section that we looked at the bridges of Ross, with our kind of three benches of A, B, and C sand, if we use that terminology. And a couple of kilometers down dip we see something similar. So why do I care? Right, this is the why do I care moment that we kind of focus on in our schools. Is that, let's say this was the exploration well you drilled, and I've drawn in basically what the gamma ray would look like of that section. And you drill an exploration well, and you know this is fairly thin, it's only about 11 meters, so subseismic, but the geologists say, okay, I can feed 3 genetic packages, an A sand, a B sand, and a C sand, and I know this is in a distributive environment, so this is more of a medial to distal lobe or lobe elements to proximal to this channel lobe transition. Great. Now hand over to the appraisal team, and they drill another well a couple of kilometers down dip, and lo and behold, they see fairly similar motifs. They say, oh, okay, I got the A sand, the B sand, or the C sand. And then what very typically happens, even though people have described the right environments and think about continuity, they will draw straight lines through here and say, I've got a high net to gross sand, a moderate net to gross, and a low net to gross sand, and I correlate these across. It happens a lot. So this nomenclature of A, B, and C, and then you get a surprise B2 sand and all that, is really kind of typical what happens. But you know, if I correlate this, and the way you should do as well, if you're a geoscientist and you think about, okay, I've got only about 11-12 meters of a few elements that make up maybe an advancing lobe, and I've got another one here, but they're 2 kilometers apart, that continuity doesn't exist. So I would actually go, and this drives people kind of mad, I would go like that and say the A sand, which is already kind of medial to distal, becomes a skinny little guy by the time I come here, and the B sand again in the more proximal part will become a more medial to distal position a couple of kilometers away. And then with that motif, over in the channel lobe transition here, you get, well, down dip, that should get into a more proximal lobe. So that surface probably comes in here, and then this sea sand doesn't have a time equivalent in the section you got there. Why does this matter? Well, as we know that each of these genetic units has got some mud associated with it before it starts prograding. So if you had drilled this well and say, well, this is my best sand and I've got that other sand here, and you expect, you know, communication across that, you may actually be surprised. It probably won't truly cause barriers, but it might cause quite baffled flow behavior that you go like, huh, I wasn't expecting that. So at the subseismic scale, really think about your depositional environment and how continuous these beds really are. In reality, they're always a lot less continuous than we typically put into the model. So that's a little learning from doing a little detailed correlation at this outcrop. All right, see you at the next one.